Today we are going to learn about real-time face detection with OpenCV. You'll gain skills in implementing face detection using OpenCV's pre-trained models for applications in human-computer interaction and security. Welcome! In this video, we're diving into the fascinating world of real-time face detection using OpenCV. Face detection is a critical technology with applications ranging from security systems to interactive media. OpenCV, an open-source computer vision library, offers powerful tools for implementing these capabilities. By the end of this session, you'll have the foundational skills to set up a basic face detection system ready for integration into larger projects. Let's explore the algorithms, tools, and techniques you'll need to master this essential skill.
Face detection begins with understanding the algorithms behind it. The most common and beginner-friendly algorithm is the HAR cascade, developed by Paul Viola and Michael Jones in 2001. This technique uses machine learning to identify objects in images or video streams. It is known for its speed and efficiency, making it a popular choice for real-time applications. However, HAR cascades are not the only option. Other models, such as LBP, local binary patterns, and DNN, deep neural networks, offer different strengths and weaknesses. Understanding these differences is crucial in selecting the right model for your project. HAR cascades are excellent for basic applications, but more advanced models like DNN provide higher accuracy, especially in complex environments. We will explore these models in more detail as we progress. To get started with face detection, we first need to set up OpenCV for real-time video processing. Begin by downloading OpenCV from the official website. Choose the version that matches your development environment, whether it's Python, C++, or another language. Next, install the necessary libraries using pip or conda for Python users. Once installed, configure your development environment by setting up video capture from your webcam or any video source. Write a simple script to ensure that OpenCV is capturing video frames correctly. This test will help confirm that your setup is ready for face detection. Remember, proper configuration is key to seamless real-time processing, so take your time to ensure everything is working as expected. OpenCV provides pre-trained HAR cascades for detecting faces, eyes, smiles, and more. These are stored in XML files that can be loaded directly into your application. Start by loading the face cascade using OpenCV's cascade classifier method. Once loaded, you can implement basic face detection by applying the detect multi-scale function on each video frame. This function scans the frame for faces and returns a list of rectangles that represent detected faces. Visualize these detections by drawing rectangles around the detected faces using OpenCV's rectangle function. Run your script and watch as faces in your video stream are detected in real time. This basic implementation can be the foundation for more complex applications.
For face detection to be effective in real-time applications, performance optimization is crucial. Start by reducing the video resolution, which decreases the number of pixels to process and speeds up detection. Next, adjust the parameters of the detect multi-scale function, such as scale factor and min neighbors, to find a balance between speed and accuracy. Lowering these parameters can increase detection speed but may reduce accuracy, so testing and tweaking are necessary. Additionally, test your implementation on different devices to understand its performance across various hardware configurations. Remember, the goal is to achieve a smooth and responsive detection system that meets the needs of your application.
Integrating face detection with video streams involves capturing video frames from a source such as a webcam or a video file. Use OpenCV's video capture function to access the video stream, then process each frame individually. Apply the face detection algorithm to each frame, and display the results on the screen by drawing rectangles around detected faces. This real-time processing creates an interactive experience where faces are detected as they appear. Additionally, consider saving the results, such as the detected face coordinates, to a file or database for later analysis or use. This integration is essential for applications like surveillance systems, where real-time detection and data storage are crucial.
While face detection is a powerful tool, it comes with limitations. Environmental factors such as lighting and background can significantly impact detection accuracy. For instance, poor lighting can obscure facial features, leading to false negatives. Additionally, face detection models can be biased towards certain demographics, impacting their effectiveness across diverse populations. False positives, where non-facial objects are detected as faces, are also a common challenge. To improve accuracy, consider enhancing the quality of input data by optimizing lighting and reducing background noise. Moreover, using more advanced models like DNNs can help address some of these limitations by providing higher accuracy and better adaptability to different conditions. For those seeking improved accuracy in face detection, exploring advanced models like deep neural networks, DNN is a worthwhile pursuit. DNNs offer significant improvements over traditional HAR cascades by leveraging deep learning techniques to better understand and recognize facial features. This results in higher accuracy, especially in challenging environments. OpenCV supports the implementation of DNN models, allowing you to integrate these advanced techniques into your applications. To use DNN, load a pre-trained model, such as a Caffe or TensorFlow model, and apply it to your video frames. The enhanced accuracy and adaptability of DNNs make them suitable for applications where precision is critical, such as biometric security and advanced human-computer interaction systems. To achieve reliable face detection under various conditions, consider these practical tips. First, enhance the quality of your input data by ensuring your camera settings are optimized for the environment. Adjust the camera's exposure and focus to adapt to different lighting conditions, and try to reduce background noise by positioning the camera to minimize distractions. Additionally, using multiple face detection models can increase robustness, as different models may excel in different scenarios. By combining models, you can mitigate the weaknesses of one with the strengths of another, achieving more consistent and reliable detection. These strategies will help you build a face detection system that performs well across a range of conditions, ensuring its effectiveness in real-world applications. Congratulations! You've completed an in-depth exploration of real-time face detection using OpenCV. We've covered everything from basic algorithms to advanced models and practical tips for optimizing detection under various conditions. Remember, mastering these skills requires practice, so continue experimenting with different models and settings to find what works best for your applications. As you grow more comfortable, consider exploring more advanced topics, such as emotion recognition and 3D face modeling. We've provided resources in the description to guide your further learning. Keep experimenting, stay curious, and continue to push the boundaries of what you can achieve with face detection technology. Thank you for joining us, and happy coding!